This integral here, number 5, looks a bit complicated because the integral looks complicated, but it's actually very easy to analyze. If you look at the interval, there's no problem in this stream here. The function is well behaved when x is close to 1 and also at any other intermediate point. I mean, there's no divergence of this denominator. There's no zeros in this denominator, so there's no problem with this function. The only problem is it is improper because the upper limit is infinity. All right, what we need to analyze this function is to figure out what this function looks like when x is very large. And that is very easy because when x is very large, the 1 here is irrelevant compared to the x squared here. And then this square root behaves as the square root of x squared, which is just x, because x is positive. So the behavior of this is this one. So this bit here behaves as x. So this is equivalent to this one. Actually, you can prove it explicitly by dividing one by the other and calculating the limit when x goes to infinity, right? Okay? But anyway, you don't need to because it's pretty obvious in this case that this is going to be what happens. So the integral we need to analyze is this integral here, the convergence of this integral here, beta plus 1. But now we know when this is convergent. This is convergent if and only if the exponent beta plus 1 is strictly larger than 1, which means beta is strictly larger than 0. So for beta strictly larger than 0, this integral here is convergent.